All right, welcome viewers. We are going to be learning completing the square today in pre-cal. So we're going to do two problems for you. The first one is going to have an a, or a leading coefficient for x squared of a 1. And the second problem is going to have a leading coefficient of something other than 1, which gets a little bit more complicated. So we'll go ahead and start. So we're not going to do, I'm also going to attach this worksheet. I'm going to start with kind of an explanation of completing the square first, and then we'll do the first problem. So when you have two binomials that are exactly the same, okay, so x plus 4 times x plus 4, and you FOIL it out, you get x squared plus 4x plus 4x plus 16, and then these two terms are like terms, so that becomes an 8x, okay? These problems that we're dealing with here are in standard form, like this one, this example, okay, that doesn't have anything to do with the problem. What we're trying to do is rewrite these standard form equations in vertex form so we can automatically see the vertex. And how we do that is when we're given an equation here in standard form, we look at the b. A is the leading coefficient of x squared, b is the number in front of x, and this is c. When we look at b, we take half of it, half of 8 is 4, and that becomes the number we need here. And then this number is 4 squared. And that makes these two binomials exactly the same. We're going to be working backwards. So normally we would, if we got a quadratic like this, first thing we always try to do is factor. Try to factor it. And say, all right, I can't factor it. Well, maybe we can rewrite this in vertex form. All right, so I'm going to go ahead and erase this.
Should we not have written that down?
No,
Oops.
it's fine. I mean, did you use pen?
No, I didn't use pen. I almost did, actually.
All right. Okay, so problem number 1. We're going to rewrite this first as f of x equals x squared plus 6x, and then we're going to leave a space, and then plus 4, and then we're going to put something else there. Oh, I forgot my, the student told me, I don't know if I told you guys yet, another pre-cal student in another class who I don't teach said that my sound was like not good on my videos. So I tried to use this. I used it one time. It actually worked a lot better. It's an amplifier. So, okay, can you hear me talk? Listen to this. Tell me if you can hear anything come out of it. Testing, 1, 2, 3.
Yeah.
Okay, excellent. All right, this goes right here. Okay, so what we're gonna do is we're gonna make this into a perfect square factors. So we're gonna take half of b, which is 3, and then we're gonna square it, and that's the number we're gonna need here. So half of 6 is 3, squared is 9. Actually, I need a different color there. Gracie taught me that. Now, before we continue, we have an equation, and it's balanced, right? We just changed it by adding 9. So in order to keep it balanced, we're going to also have to subtract 9 on the same side of the equation. So after the 4, I'm going to subtract 9. Now it's completely balanced. We haven't changed the value at all. But now we can rewrite this in a different color. I'm just going to put an equal sign as x plus 3 times x plus 3, which I'm just going to write it as x plus 3, the quantity squared. And then 4 minus 9 is minus 5. So now we've just got f of x equals x plus 3, quantity squared, minus 5. So the vertex is at -3, -5. And it's ready to immediately tell what the vertex is, and also we could graph it using transformations, right? We'd take x squared, we'd move it left 3 and down 5. Done. It's much more difficult to do that with the equation in standard form. How are we doing? Do you guys like my hat? Nick let me borrow it for my video. So amazing. How are we doing? Questions yet? I'm standing in front of it. Do you guys remember this from Algebra 2? Did anyone learn this in Algebra 2? Two people said yes. That's awesome. All right. I'm going to erase this -9 just so I have space here. So I'm trying to write larger for America. Okay. Second problem. We have a leading coefficient of a 3. So the first thing I'm going to do is pull that 3 out or factor out that 3. Rewrite what I have left in here. I'm just going to pull it out of the first 2 terms, and I'm going to put the -18 at the end here. So if I pull a 3 out, so 3x squared, if I divide that by 3, I get just x squared left, and then the 12x, that will be 4x, and then a space, and then a space. Now what we're going to do here is we are going to complete the square here, and then we're going to balance the equation. It's a little trickier because we have a 3 in front. So let's go ahead and focus here first and balance. Half of 4 is 2. 2 squared is 4. So I'm adding 4. Now, we didn't actually add a 4. This 4 is inside this parentheses that is being multiplied by a 3. So technically, that's a 12 that we just added to that side of the equation. So we have to, what do you think, what number are we going to put here? Exactly. Now we continue in a different color. The 3 is in front. This is x plus 2, the quantity squared. And then -18 minus 12 is -30. So the vertex is at -2, -30. That's it. How are we doing? It's so much easier in pre-cal to learn this than Algebra 2. Oh my gosh, you guys, come get on my video. I'm recording right now.
Oh my God,
I'm getting a delivery. I got a delivery yesterday during my video too.
Ho, ho, ho.
Yes.
Heritage Santa hats.
Heritage Santa hats. You guys, I want a delivery in every single one of my videos. They're required. Okay, hold on. Oh, I think Eric needs one too. Didn't Eric buy one?
Yes, Eric has one. All we need in exchange is that card that I gave you, if you still have that.
Yes, I have the cards. I can give that to you. Matt, this is amazing. Love it. I'm gonna wear this every day. I'm gonna wear it with my onesie on Friday.
Beautiful. It fits you so well this summer.
Thank you so much. Let me give you the cards.
Completely square. Oh, that's.
Do you want to say hi to America?
Hi, America. Miss Hubbing's awesome. Thank you, Miss Hubbing. Beautiful.
Thank you.
Enjoy
Thank
your
you.
day.
Thank you very much. All right, are we done? We're done. That was awesome. Okay.